In this video, I'll be dealing with a question to do with Pythagoras theorem problems, which doesn't really have a right angle triangle that is present yet, but you see later on. This is one of the interesting questions I really like because, well, in this rectangular prism, you can see there's no right angle triangles, but we can create a lot of them. So the question 2, it says, find the correct to one decimal place, the length of HD. Okay, so I was talking about those right angle triangles, and now HD, okay, can be an edge of a right angle triangle. And the one I'm going to look at here is this one here. Okay. So the part that is right angled is actually at the very corner here. All right. So this line and this line, okay, is basically the lines of a rectangle if I was to look at it from the top view. Okay, that's that right angle right there. Now, that triangle that we can see already has some measurements. This is 6, and this length here, which is basically this one here, is opposite this one, which is 15. Okay, so this length here is that. So we'll call that 15 meters for now. Now, if I was to redraw that triangle out, okay, I'm just going to redraw triangle HGD right there. You've already got 15 there and 6. Whoops. So if you want to find out what the length of HD is, HD squared is equal to 15 squared plus 6 squared. So 15 squared plus 6 squared is 261. Now, if I take the square root of both sides, I will be able to find out HD. So HD would equal to the square root of 261, which is going to be 16.15 dot dot. Okay. So if I was to round that to one decimal place, like it says so, then it'll be 16.2 meters. Right. Now, if I wanted to find out DE, which is this line here, okay, I'll just make this less thicker. Yep, DE. Okay, can I create a right angle triangle using that purple line as an edge? I can actually do that. Okay, so I'm going to use this line here, EH, as well as this line here, DH or HD, which we found already. Now, this angle here on the very corner is a right angle, right? So this line on the bottom rectangle, as well as this vertical line, must create a 90-degree angle for the rectangular prism to be upright in shape. So we've actually got two measurements here. We've got this, EH, which is just the height of the rectangular prism anyway. That's basically the number 5. So I'm going to label 5 right there. Then DH, we already found as well. That's 16.2. Okay. Now, if I was to do this exactly, I would use HD as this value instead of this value. Okay. Because this is a random value, which if we use again, it's going to cause a slight error in our solutions. So this is much better. So I'll teach you how to do this. In this triangle, for question B, I'll draw it out. I have a right angle there. I have HD being this and E being here. We said this length here was 5, which is this. And HD here is going to be this value here, which takes the square root of 261. And now we're trying to find out what ED is, okay, or DE is. So DE squared would equal to the sum of the squares of the other two sides. Okay, so I'll have 5 squared plus the square of 261. Now notice how I said square of the square root. What happens is that the square and the square root will cancel each other because they're inverse operations of each other. If you actually type this on your calculator, you actually get this equal to 261 because these two cancel out. So you just have to read whatever's inside. So if I was to just use my head for this instead of my calculator, 5 squared is just 25. That's 5 times 5. The second bit is 261, as we discussed before. And 25 plus 261 would give us the e squared, being 286. Okay, and remember just to write down all of this. Okay, it's very important that you write down this. Then you would take the square root of both sides, like so. So if I take the square of the left side, this will cancel out with that square there. So dE is equal to the square root of 286. And if I take the square of that, then that would equal to 16.91, so on, which does round off to 1 decimal place as 16.9 meters. Okay, and that's how you do question 2. Moving on to question 4. Okay, 3 is something you can do yourself. It follows the same process as question 2. But for question 4, for this square pyramid, find the slant height EF correct to 1 decimal place. So we're trying to find out this length here. Okay, now that length there is not too bad to find. We've already got our vertical height, 18, which is actually simply just this line here from the center of the bottom shape, which in this case is a square pyramid, so it's a square at the bottom, okay, over here. So this part that I've drawn is 18 centimeters in height. I read it wrong. Whereas the 8 on the bottom is the distance from A to B, or this distance here, which I'm drawing also, but halfway, okay, or half of that, sorry, I should say, is going to be 4. Okay, so that bit there is going to be 4 centimeters. So now we've got a triangle that's right angled. That looks like this, where we've got E, F, and because there's no letter there, I'm just going to call this O, okay? Some letter that they haven't used. So call this O, and our 18 centimeters is our height here. We've got 4 centimeters spanning across from O to F, and we've been asked to find out what the slant height EF is, okay? So slant meaning it's not vertical, okay? So it's this one here. So if we find EF, we're going to square that first, equal to the square of the other two sides summed up together. So 18 squared plus 4 squared on the calculator does give us 340. And then we're going to take the square of this side, becoming EF, and square of this side, which becomes the square root of 340. So the square root of 340 is 18.43, and so forth, the 3 dots at the end. So if I round that to 1 decimal place, that's 18.4 centimeters.